Hi boys and girls, my name is Miss Connolly. I'm making videos for my students and I want to make sure I shared them with all of you so we can get as many students learning as possible during this crazy time. So if you have a topic you want me to cover, parents, teachers, students, anybody, connollymathathome@gmail.com. And also make sure you like, subscribe, and share it with a friend so that we can get as many students learning as possible during this crazy time. And today for math time, we are going to be thinking about decimals. So the last two videos were about what happens when we multiply, but with a decimal involved. So we are going to continue that work, okay? So make sure you watch multiplying by powers of 10 and the first video about multiplying decimals, because I only used decimals that went to the tens place and only one of the factors had a decimal. So today we are going to be thinking about when both factors have decimals involved, and we're going to be thinking about when one of the factors goes to the hundredths place. Okay, so let's get started. As a review of the other videos, we thought about when we were multiplying with decimals first, we estimated. That's going to be really important. Next, we used strategies that we would use to multiply whole numbers, and then finally we placed the decimal where it would make sense. We thought about our estimation, and we thought about what was happening to the size of the factors, and so what would happen to the size of our product. Okay, so we're going to give that another whirl here. So first we are going to think about 7 groups of 1500ths. Okay, and we can think about a little snail crawling along at 1500ths miles per hour, so really slow. And that snail is working hard for those 7 hours, okay? So 1500ths of a mile per hour for 7 hours. How far do they travel in 7 hours? So first, we need to estimate, okay? So when I'm thinking about this, I look at the numbers and I see 1500ths, and I know a lot about rounding decimals because I watched Miss Connolly's rounding decimals video, and I'm thinking that 1500ths is close to 2/10. So I'm going to think about, there's a couple different ways we can estimate here, but I know that 7 groups of 2/10 is going to be 2/10 plus 2/10 plus 2/10 plus 2/10 plus 2/10 plus 2/10 plus 2/10, and that's going to be 14/10. So when I think about 14/10, for example, I know that's 1 and 4/10, which can be written as 1 and 4/10. Okay, so there is this flexibility that we have here between decimals and fractions. Want you to be using it. Another thing that you might want to think about is rounding the 7 hours up to 10 hours and thinking about 1500ths and thinking about how 10 groups of 1500ths would be 150 hundredths, which is the same as 1 and 50 hundredths. Okay, so these are 2 different ways that we can estimate. Are there more ways? You bet there's more ways. You get to think about how to estimate. So these are my estimates. I'm going to think about 1 and 50 hundredths, and I'm going to think about 1 and 4/10. And then I'm going to use those estimates at the end to think about where I should place my decimal. Okay, so we've estimated. Now we're going to multiply as if we're multiplying whole numbers. Okay, so I'm going to think about this as 7 groups of 15 instead of 7 groups of 1500ths, because I know how to multiply whole numbers. Okay, some of you, like I said this in the last video, the standard algorithm is not always the most efficient way. So right now what I'm going to do is I'm going to think about multiplying, keeping 7 whole and multiplying and breaking 15 into parts by place value. So I'm going to think about 7 times 10, which is 70. I'm going to think about 7 times 5, which is 35. And this also might be being calculated in your head. I'm just writing it down so people know what I'm thinking, okay? So 7 times 15 is 105, okay? So now we need to come back to our we originally estimated that 7 groups of 15 hundredths would be somewhere around 1 in 50 hundredths or 1 in 4 tenths. Okay, we did round up for both of those estimates, just so you remember. We did 7 groups of 2 tenths, or we did 10 groups of 15 hundredths. So both of these estimates are a tad bit high. Just to remind you, after you estimate, you have to make up for that and think about where your actual answer might fall. So just a reminder about that. So if I'm thinking about where the decimal should go, so this makes sense, I'm going to look at my options. So first option I could do is I could put my decimal here. Or I could keep it 105, but we know that's way off, so we ain't going to do that. All right, so 10 and 5 tenths. So I asked myself, does that make sense with what I originally estimated here? And it doesn't. Okay, so we're going to say that doesn't work there. All right, we want something that is 1 in 50 hundredths, 1 in 4 tenths, or lower, because we know we rounded up when we estimated. Sorry. So we are going to see if the decimal works there. And I'm wondering if you think that 1 in 5 hundredths is a reasonable answer for this situation. And I think that based on my estimate, based on the numbers given to us, that 7 groups of 15 hundredths, it makes sense that it's 1 in 5 hundredths. Okay? So that's one way we're going to figure these out, is we're going to be thinking about our estimate and what makes sense. And the other thing that we can do is we can think about what happened to our factor. So what happens to our product? Okay, so what's going on here from here to here is really important. So these are my whole numbers. I am thinking about, what did I do to this factor to make 15 hundredths? Because whatever I did to this factor, I'm going to have to also do to the product. Okay, and by the way, this is not correct right now. I'm going to place the decimal in just a moment. So I asked myself, what did I do to get from 15 to 15 hundredths? And what happened was 15 got 100 times smaller. Okay, so 15, if I had divided 15 by 5 or by 10, sorry, if it got 10 times smaller, it would have been 1 in 5 tenths. Okay, so if I had done 15 divided by 10, I would have gotten to 1 in 5 tenths. But I'm seeing that my digits shifted 2 times to the right. Okay, so I'm seeing that this digit 1 used to be in the tens place. It got 10 times smaller here, 100 times smaller here. If I moved one more, it'd be 1,000 times smaller. You see where all of this connections with tens, hundreds, thousands? All right, so let's look at the 5. The 5 got 10 times smaller. 5 divided by 10 is 5 tenths. 5 tenths divided by 10, or 1/10 of 5 tenths, is 5 hundredths. Okay, so when I think about the value of each digit, how much smaller they got 100 times smaller. Okay, when I'm thinking about 15 divided by 100, I see 15 hundredths. Okay, so that's how I know this got here. And so what I have to do is I have to make my product 100 times smaller. So this factor got 100 times smaller, so my product is going to get 100 times smaller. So I'm going to think about 105 divided by 100, and I know that that is 1 whole. Well, I'll write it as a fraction first. You can use fractions this whole time. I know that's 1 whole in 5 hundredths, which is written as a decimal, 1 in 5 hundredths. So where do I place my decimal? Right here. I also want to think about each digit getting 100 times smaller. So 5 has to shift the tenths, or the ones place to the tenths place to the hundredths place to get 100 times smaller. So it shifts 2 times to the right when it gets 100 times smaller. That's interesting. Then the 0 will shift into the tenths place, and then 100 divided by 100 is 1. So it got 100 times smaller. Okay? When we're dividing by 100, another thing that you're going to hear and be thinking about is if I take 1/100th of this side, because I took 1/100th of 15, I also have to do 1/100th of 105. Okay, so when we're thinking about it getting 100 times smaller, you're thinking about 1/100th of this side of the equation. So you take 1/100th of this side of the equation. Okay, specifically I took 1/100th of 15 and did 1500ths. All right, so let's do another example where we have a decimal that goes to the hundredths place so we can see it again. We are going to think about 22 groups of 28 hundredths. Okay? Again, first things first, we're going to think about estimating, and I am going to think about 22 as it is close to 20, so that's going to be where I round there. And then I'm going to think about 28 hundredths, and I know that's close to 3/10. I'm still getting familiar with multiplying decimals, so when I estimate, I'm going to think about 20 groups of 3/10 because that's something I'm a little more familiar with. Okay, so I know that this represents 3/10 20 times. Okay, so 20 groups of 3/10, or we can think about it a little bit different, but just stick with me for that part, this part of it. You can think about it several ways because order doesn't matter when we're multiplying, but I'm going to think about adding 3/10 20 times. So I know if I did 20 groups of 3/10, I would get 60 tenths, which is the same as the number 6. Okay, 20 groups of 3/10 here would also be 60 tenths, and we would write that like this because 60 tenths is equivalent to 6 wholes. Okay, so let's put my estimate up here. I'm estimating 6. I rounded 22 to 20. I thought about 28 hundredths, that's close to 3/10. And so now I'm going to solve. All right, I will allow us to use a standard algorithm. Are there other ways to multiply this? You bet. You can do any way that you want. But just as a review, 8 times 2 is 16. 8 times, well, it's 20. It's so hard not to think about place value. But we'll think about just the digits in the standard algorithm. 8 times 2 is 16 plus 1 is 17. We put the 0 here in the second step every time because we're really doing 20 times 2. So we'll think about that. Think about this. And we combine. Okay, so when I think about 22 times 28, whole numbers, I get 616. And I'm hoping that you're looking at my estimate and saying, I know the answer, I know the answer. So let's think about it. If I know that when I estimated, I knew my answer had to be close to 6, you can predict where this decimal should be. Because we want a number close to 6. Okay, so that estimating is really going to help you. What else helps you is thinking about what happened to one factor. In this case, it's one factor. We're going to go over some other situations in a second. But I asked myself how many times smaller did 28 get when we're going from 28 to 28 hundredths. And I know that this factor got 100 times smaller. Okay, so if I take 1/100th of this factor, I have to take 1/100th of 616. Okay, so 1/100th of 616. We can think about it a lot of different ways, but I'm going to think about this as 616 hundredths. So how many full groups of 100 do we have? 6. How many hundredths are left over? 16 hundredths. And we can think about that. Also, another fun thing that's happening is, as you know, each digit, the value of each digit got 100 times smaller. So the digit shifted 2 place values to the right, just like it did from this factor to this factor. It shifted 2 place values to the right. Okay, so this used to be in the ones place, now it's in the hundreds place. It went tenths, hundredths, 2 place values. This was in the tens place, it went 1/10. Now that was 2 place values. This was in the hundreds, it went tens, ones. So don't forget what you know about when a digit or when a number gets 100 times smaller, the value of each digit also gets 100 times smaller. Those digits are shifting. If it's 100 times smaller, they shift 1. That's 10 times smaller. 2, 100 times smaller. And guess what? 3, 1,000 times smaller. Just so you know. Okay, so that's what happens when one factor gets 100 times smaller. Your product gets 100 times smaller. But what happens when we have a decimal in both factors? What are we going to do? All right, so we're going to do the same thing we just did, and we're going to think a little bit deeper about it. Let's use a different color. I'm sick of the blue. All right, so we are going to think about 6 and 5/10, groups of 6 and 4/10. Okay, so I was walking at 6 and 4/10 miles per hour. I did that for 6 and 5/10 hours. So I did 6 and 5/10 groups of 6 and 4/10, and I need to estimate first. Okay, so let's think about it. You watched my rounding decimal video, as we've already talked about. So I'm going to be thinking about 6 and 5/10 is close to 7 wholes. I'm going to think 6 and 4/10 is close to 6 wholes. So I think that my estimate might be somewhere around 42. Okay, so 6 and 5/10 and 6 and 4/10 I think might be somewhere close to 42, but we're going to find out. Okay, keeping in mind I rounded up for 6 and 5/10, I rounded down for 6 and 4/10, so I just want to make sure when I get to my final answer that it definitely makes sense. All right, so next we think about whole numbers. So let's do that. 65 times 64. Okay, again, any way you want to multiply is fine. There's several different ways to get at this. I don't know why I'm doing the standard algorithm a second time in a row, but I am, so just go with it. Okay, just a quick review, something you already know how to do. So, when I multiply with whole numbers, 65 times 64, I end up with 4,160. So, I bet some of you are shouting, I know where the decimal goes because of your estimate. That's the point of estimating. Okay, so let's think about if I had 4,160, I would have to think about where that decimal goes, and I can use my estimate to help me. What makes sense when we're thinking about 6 and 5/10 groups of 6 and 4/10? Well, I rounded and thought about whole numbers, and that's going to help me decide where the decimal goes. So here does not make sense. If those decimals weren't there, the tens place wasn't there, 6 times 6 would be way more than 4. Okay? 6 times 6 again, way less than 416. So I know what makes sense is that my decimal goes here, and it's 41 and 60 hundredths. But we need to talk about why, all right? So you noticed that 65 got 10 times smaller. 64 got 10 times smaller. But our product didn't get 10 times smaller. If our product, this is wrong, so just so you know, if our product got 10 times smaller, would be there. So why did our product get 100 times smaller? And this is one of my favorite things to explain. So let's talk about it. All right, what happened? I need more space. Miss Connolly needs more space. So we had 65 times 64, and that was 4,160. What happened was I took 1/10 of 65. So this 1/10 of 65 would be 6 5/10. So it got 10 times smaller. That's what's happening here. Then I took 1/10 of 64. These both got 10 times smaller. Okay, so when we're multiplying, order doesn't matter. So take a look at this. I'm going to take the 1/10 here. I'm going to take this 1/10 here. I can keep my 65. And, oops, and I can keep my 64. Okay, so I want us to think about this part here. What is 1/10 times 1/10? You know this because you know numerator times numerator, denominator times denominator. What we end up with is 1/100th of your 65 times 64. So if I'm taking 1/100th of this side of the equation, guess what I do to the other side of the equation? I take 1/100th of that side. So when each factor is getting 10 times smaller, this, and I'll write it down. Let me write it better. So when this factor gets 10 times smaller and this factor gets 10 times smaller, our product gets 100 times smaller because it got 1/10 smaller for this factor, and then I had to make it 1/10 smaller again, or sorry, 1/10 of, sorry, 10 times smaller. Let me start over. So what happened was this factor got 10 times smaller. So I had to make my product 10 times smaller for this factor. This factor got 10 times smaller, so I had to make it 10 times smaller again. And when you do that, 10 times smaller, 10 times smaller, you're making the number 100 times smaller. And you saw that when I got to 1/100th with a fraction. Okay? So that's what's happening. If one factor gets 10 times smaller, the product gets 10 times smaller. If the other factor gets 10 times smaller, then the product has to get 10 times smaller again. And if I shift those digits 10 times smaller and then 10 times smaller again, each digit got 100 times smaller. So that is why that's happening. So let's take a look at one more, and then you're going to do some on your own. See how this estimate thing worked though? I mean, that's amazing. Okay, amazing. You see it right away. I want you working on that. All right, last one. 1 and 2/10, groups of 2 and 5/10. Okay, so I am walking very, very slow. Actually, I don't know if that's slow, but 2 and 5/10 miles per hour. I'm doing that for 1 and 2/10 hours. How far have I walked? I gotta estimate. So I'm thinking that 1 and 2/10 is close to the number 1. I'm thinking about 2 and 5/10. I could round that to 3, but I want to I just want to remember that I did round up pretty far. And so I'm thinking my estimate would be somewhere around the number 3. So I'm going to put my estimate up here as 3. I'm just taking notes so I don't forget. All right. Then we're going to think about this as whole numbers. Let's do it. Let's think about 12 times 25. Ooh, 25 is fun to work with, so I'm not going to use the standard algorithm. I'm going to keep 25 whole. I'm going to split this number up into 10s and 1s. Not the only way to do it, just how I'm doing it right now. 25 times 10 is 250. 25 times 2 is 50. So what did I say, 250 plus 50? 300. Let me just make sure I'm doing that right because I talk too fast. 250 plus 50 is 300. I love estimating. Okay, so I'm thinking about where would my decimal go so that I can, so it matches what I estimated. Okay, so when we think about where would our decimal go so that our estimate gets close to our estimate, which is 3, voila. Then I also, that's a really funny looking decimal, sorry about that. I also want to think about what happened to each factor. So 12 got 10 times smaller. 25 also got 10 times smaller. So if I make this 10 times smaller, I'm at 30. And if I make it 10 times smaller again, I'm at the number 3. And since I did 10 times smaller, that's the same as my product's getting 100 times smaller. So 300 divided by 100 would be 3. And that's how we can think about that. So I'm going to give you something to try on your own. A nice little mixture. You're thinking about estimating. Multiplying like your whole numbers. Any strategy you want. Pick the best one for the numbers you're given. Okay? Then you're placing the decimal based on your estimate. Or you're thinking about what happened to each factor and what needs to happen to the product. Okay? Now you have to consider more than just one. The last video you were just thinking about one factor and getting 10 times smaller. Now you have a mixture of one factor getting 100 times smaller, or one factor getting 10 times smaller than the whole number I'm talking about. Or you might be thinking about both factors getting 10 times smaller. I might even throw in another thing that might confuse you just to challenge you. So let's see what you're going to work on at home. All right, I want you doing 3 and 7/10 groups of 1 and 4/10. Okay, estimate first. I want you doing 25 groups of 4/10. I want you doing 3 and 4/10 groups of that one's going to be a challenge to you. Okay, I love challenges, it's so exciting. And then finally 4 groups of 1600. Okay, sorry about my excitement, but you noticed something happened. So I wonder how much smaller your product has to get, how many times smaller. Think about it. Okay, bye.